Okay, so welcome to our third class. This is the third class on emerging technologies for lifelong learning. Once again, it's not about packing as many emerging technology subjects as we can in a semester. It's more about teaching you the skill set to acquire knowledge on emerging technologies using a couple of items that are relevant as of today, 2024, basically as example case studies, right? These are basically handpicked by me, I guess, as the relevant key technologies area that are considered the most impactful, right? But then, of course, you can think of area of emerging technologies of your own interest, particular specialization, and those will be the very subject of your term study or term project. Okay, right. So, what did we do in class number 1, in the first class? Class number 1 gave you the sort of like philosophy of learning. I guess this is basically what Basai is new and somewhat different from other departments or faculty within Chulalongkorn University, where it is basically a focus on subject domain. This is more about your being able to integrate multidisciplinary knowledge. And of course, you can't know everything before you integrate them, but you can't integrate things that you don't know. So you have to be able to have the special skill set to maybe acquire knowledge to the level where at least you would know what the key technical issues are. And if you don't solve them yourself, then at least you would be able to point yourself in the right direction. Okay. So, let's say this kind of emerging technologies area requires special knowledge in nanotechnology or nanoscience, and that will point you in the direction of that. And then you survey and maybe have a friend or colleagues from that part of Chulalongkorn University, and then you can collaborate. Okay. So in a way, I think of you as supreme collab guys. Guys who can design sneakers but really don't know how to make sneakers, and they do collab with, I don't know, Nike, Adidas, or whatnot. Okay, so these guys can be singers. They know nothing about shoes, but they know a bit because they wear them. They have experience with design or fashion items, so they give their input. And on the other hand, the technical know-how, how to make shoes and how to produce that's not something that these artists knows, right? So it's a little bit like that. So you guys are a little bit like that, right? Okay. So the first day is philosophy on your education, and how does emerging technologies education is relevant and how things are changing. And your generation not only has to deal with emerging changes, your generation also has to deal with the problems that maybe my generation created for you, the ecological impact, global warming, and whatnot. Okay, so yours have to be a generation of solution. Okay, right. So we went to the second class, right? The second class is kind of split into 2 halves, if you recall. So the first half was, I guess the theme was the road to hell is paved with good intention. Okay, so all the good intention, even forethought, well-designed engineering, scientifically inspired innovations can lead to catastrophic consequence. Okay, so that was the theme. So all kind of innovation, and of course I came from financial risk management background, so I give you a lot of financial crisis example. Okay, but of course there are plenties, and the usual story people talk about would be like, for example, thalidomide, which had a side effect of severe birth defect, or CFC, or or even the fact that internal combustion engine automobiles were conceived originally, was popularized not for convenience or performance, but as a solution to pollution, right? Where cities were overcome with horse doo-doos, and so clean internal combustion engine was the solution to pollution at that time. Okay, and then it goes fast forward. Now, there's another story about why was it that the internal combustion engine based on fossil fuel took off. Why did that take off instead of more electric power, which was at the same time very competitive technology? Maybe that has to do a little bit more with, I don't know, monopoly and political, economic, business maneuver. But anyway, the point is whether or not we're talking about electric vehicle or internal combustion engine automobiles, they would have been seen as a relief, right? Something that was clean. You can really walk behind an automobile, even though back then it was probably dirty, much dirtier than today. If you walk behind an automobile in 1900s, it certainly was a lot more pleasant than walking behind a horse-drawn carriage, right? Good. So that was the first half of last week. And then the second half was more like the philosophical and methodological antidote to preempting, right? Preempting all this negative, unforeseeable consequence, as well as being resilient to it. So that was the paradigm of sufficiency economy philosophy, where the key cornerstone were predicated on the three concepts, right? The moderation, economics of moderation, the causal nexus thinking, and the sort of prudence or resilience based on, immunizing your population, immunizing your society. Okay, and immunization, as you know, medically as well as metaphorically, immunization is an education program. In other words, if you're going to immunize yourself against vaccine, what you do is you educate your immune system as to what potential pathogen looks like, right? The protein signature, the spikes, and the whatnot. So you educate. And I think, I don't know, when you were kids, you have Nitan Aesop or not, the Aesop fable. A lot of Aesop fable. Okay, a lot of Aesop fable is about learning from your neighbors. Okay, so learning from your neighbors' mistakes. So that's the form of immunization, right? Because Thailand was immunized against 2008 crisis because we suffered the 1997 crisis. Now, you can imagine what if another country looked at Thailand's 1997, learned from it, and also was immunized against 2008. Okay, so that's a form of immunization or resilience. That is the third pillar of a principle in sufficiency economy philosophy, right? And so I gave you, I think, an assignment to think of something and try to sort of like look through the filter, the triple hoop filter. Okay, so let's come to today. Now, today is all about, well, in a way, equipping yourself with tools, actual tools now. Okay, not philosophy, not lessons, not framework, but literally tools for you to learn new things. Okay, I put a lot of emphasis on online facilities that, for very little amount of money you can benefit from, all this I don't know, Coursera style, brilliant.org, all this kind of a learning platform online. It's very good. Khan Academy, I'm not sure if that used to be very popular at one time. And of course, if you actually go through the syllabus, right? By the way, I did revise the timeline for the syllabus a little bit to reflect moving classes around. Oh, that reminds me. Okay, when your friend gets back, I have to ask you about makeup class. Okay, so we have to look at the time. Good. So if you look at, now let's go look at, so I started this, so let's go look at your class, right? Syllabus, okay, I'll hand this out to you later, in line group. Okay, so if you come down here, all the way to the bottom, a lot of these are things that you can, go online and read and pick up, okay? And finally, down here, 15.4. These are, now this could be a little bit outdated because I actually drew this a year or two, maybe 3 years ago. These are the sort of like channels on YouTube, which I find to be very much focused on emerging technologies, okay? So the example that we use about biodegradable plastic, I think was, it belonged to the Seeker channel, okay? Sensu, I'm not sure if that's active now, I haven't seen that for a while. Just have a think, it's a very good online guy who focused very much on the global crisis. Veritasium is a mix between science education and technologies. 2-minute paper, these are guys who are into AI and all that. 3 blue, 1 brown, this is like, by the way, these two I like so much, I think gave some money for patron subscribe, but not much, but anyway, so this was the early day of patron when I was saying, okay, well, let's try to subscribe to some. Now you can actually directly thank them with the points or whatnot. But 3 blue, 1 brown is probably the best mathematical scientific visualization, right? Quantum magazine along the same line, real engineering, curious drawing, all this stuff, TEDx, of course, free documentary. Lex Friedman is a lot more like a long form thing. So it's a podcast interview, it's very long form, very insightful. Some of the smartest people alive right now who are not only smart but active. There are people who are smart but sort of like keep themselves in the cell block somewhere in the middle of Siberia. But these are smart people who are active, building things, creating things. Would go on interview with Lex Friedman. Okay, Lex Friedman, I think it's a Russian by training. I think he's a physicist, but he's very smart kid. Okay, and I have all kind of my own links on various bits and pieces. Okay, so, and all this you can almost find online PDF of it as well. Okay. Now, one of the semi assignment I gave you last week was not last week, probably from week 1, was start thinking about your topic, right? Your particular topic. I'm not gonna ask you that right now, but after the break, maybe I'll go through each one of you and just sound out the area. Okay. Okay. So these are kind of like online resource. Okay. Now, online resource can be very good, produced very well, but depending on your search history, you can actually go down a wrong rabbit hole. There's a lot of fake science out there, okay? There's a lot of fake science out there that sounds, production value just as good as any of the channel that I show you, okay? Except you'll come out the other side thinking that, I don't know, the earth is flat or something, okay? There are people like that, and they don't come out and say this is a flat earther, but eventually it kind of leads you down the silly rabbit hole. Okay, so be a little bit careful. That's all I'm saying. Okay. Likewise, what is the new source of learning, by the way, that I didn't put in this here, which was not widely available 2-3 years ago when the course was first designed? Of course, the world of ChatGPT, right? Now, let me see if I can do this. Share. Am I logged in? No, I'm not logged in on this machine, so I might show you a little bit. Well, anyway, okay. ChatGPT is one of those things where think of it as somebody trying to please you. Okay? And the nicest way, the easiest way of pleasing you is giving you what you expect. And that's what generative pre-trained large language model does. It literally does nothing more than predict the next word. Okay? But that's so in a way that is consistent with the huge volume of literature that's out there. As such, did your mom have to go home and fetch your computer? Oh, okay. 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 Anyway, very good. As such, okay, as such, one of the most deceptive thing about ChatGPT is that because it's literally a language model, it sounds so convincing. Okay? In fact, the language that ChatGPT speaks is perfect universal English. Okay? If the world detracts from proper grammars a little bit, so will ChatGPT. So it reflects the human population, basically, right? And that's the reason why when you read response from ChatGPT, it's so believable. Okay? ภาษาไทยเรียกว่าเนียน Okay? You can't, from the sound alone, say that it's something fishy. I tried something very funny. I can ask something about the Buddhist concept in Bali. It gives you something almost as if it was delivered by a monk, but complete nonsense. Okay? So you don't rely on ChatGPT for factual. The best thing you can do is think of ChatGPT as very good arranger, very good butler. You guys know what butler does? Or I don't know if you have this. Well, this is not a tradition you see nowadays. In the old days, when you go to a new town, okay, you don't have TripAdvisor. You go to a hotel, you check in, and the guy who opens the door is the one who suggests everything there is to know about the city. Where to eat, where to shop, what not. Okay? Now, this guy could be biased because his cousin runs a tourist shop. So he's going to say, hey, go to this place. Fine. So you can't really rely on him for fact either, but he's trying to please. So he's giving you the answer in line with what you want. But you can't rely on him for fact. Now, with ChatGPT, free ChatGPT, that's basically, you can think of it as a very enhanced Google search. Okay? Now with ChatGPT, the version that you have to, put some money in, it gives you a lot of back-end add-in. And some of the add-in is actually like PDF reader. It would actually fetch actual documents, read it, and try to summarize from that. So to the extent that the source is reliable, so is this. Now for something more, I wish I should have locked in this, but anyway, not to interrupt the flow, I'm just not going to take time. One of the backend, okay, one of the most popular backend is called Wolfram Alpha. Okay, so that's so basically what this means is that when you don't pay for this, you pay for ChatGPT Plus, and that gives you a link to 50 other add-in. I think you can load 1 or 3 at a time or something like that. But one of the most important thing is for factual, for computational, for analytical backend, it actually connects to what's called Wolfram Alpha engine. Okay, so it does all kind of stuff. Now, if you were not Basai student, this is how I would teach this class. Maybe I'll ask you to pay subscription or something, because you can hook onto any of thing. Okay, you can learn about music theory, I don't know, Pokemon, mathematical function, algorithm, audio, codes, all kind of stuff, right? All this kind of backend. Okay, So this Wolfram is kind of like what's called computational intelligence. So it's not like Wikipedia where it gives you dry fact. This is kind of give you fact that you can then take as an object and then plot time series. Okay, so if I look up things like I don't know, carbon, how many parts of carbon part per million in the atmosphere, okay? That'd be like 400, and if you go to Google Wikipedia page, maybe there's a link, maybe there's a plot, okay? Whereas if you did this in this Wolfram Alpha engine, you would actually go to the time series of the how many parts per million of carbon dioxide or carbon particulate in the atmosphere, okay? And then you can see that there's a big hockey stick shape around the Industrial Revolution up to the present, okay? And then you can do analysis and do all kind of stuff. However, this Wolfram Alpha is actually embedded within Wolfram Mathematica, which is what you guys have, okay? So that part, that bit about computational knowledge or factual knowledge that you can graph, you can plot numerical data, things that are factual that you can be sure if you ask ChatGPT to access Wolfram Alpha to fetch information, it's going to be reliable because it's curated. Okay. Now, sometimes you have to prompt, sometimes you don't have to. I notice sometimes I ask some factual or quantitative question prompt to ChatGPT. It's just going ahead and give an answer. It thinks it's no. But for some, if I want to be really certain, I say, please go to, don't do this yourself. Don't answer from your feeling. Go to Wolfram Alpha and give me an answer, the right answer. It would go to Wolfram Alpha and fetch me the curated data. Okay. Now, so I'm not gonna have you start ChatGPT, add the Wolfram Alpha add-in, and then explore the learning module from there. Okay, even though that is not available, but because you have something more expensive, which means that you actually go to Wolfram Mathematica itself. Okay, so start your Wolfram Mathematica right now. You should come up with a blank page. Okay. Now, some of you have done maybe Python programming using Jupyter Notebook. You'll be familiar with the interactive mode with Mathematica. And I'll tell you the good reason for that, because developer of Jupyter Notebook got the idea from Mathematica, not the other way around. Okay, so you have this thing where you got this little cell, this little, nested cell. You can see that in Jupyter Notebook. That's taken from Wolfram Mathematica in the 70s, I think, if I'm not mistaken. So if you're from a coding perspective, think of this as coding interface, right? Coding interface. But of course, a lot of you, and I assume most of you, or a large chunk of you, are not going to end up as that proficient in coding. Okay, so don't think of it that way. Okay, think of it as computational intelligence desk. Okay, so this looks blank right now. Okay, now some of you who came from a more very forward thinking or forward high-tech high school may have used interactive textbook. I don't know if you have before. It's a little bit like textbook that's in PDF, except instead of just going down, going up, you can do some kind of interaction. Well, this is a little bit like that. So I actually wrote this. This is going to be a textbook. Okay, but it's interactive textbook because not only do I have text here, there are, things that I can shift enter. Okay, anyway, so this would be like functions. Now, I'm going to be using some of this, but this is taken from my big data class or data analytics class. You guys are not in a data analytics class. We're not going to be going through this whole book. I'm just going to be using that chunk that introduce functionalities and how you interact with Mathematica. Okay, so if let's say this is my chapter 1, this is introduction to data analytics. Remind me later. Okay, so this one is not relevant to you. Okay, so this one. Okay, so basically you can see that I have chapter interactive visualization. We might do a little bit of that, but now we got to probability. All this is not part of the class. So today we actually might. Okay, now I can make this look like a textbook. I can make it look like a PowerPoint if I like. Remember I told you the PowerPoint's very good, but it's a little bit too linear to my liking. Anyway, so okay. So with that, okay, so I started by saying you can go to ChatGPT, but something more analytical, you can hook to the back end, Wolfram Alpha add-in. But now we're doing the opposite. We actually, well, not doing the opposite. We actually go to the original source of Wolfram Alpha, which is Wolfram Alpha as part of Wolfram Mathematica. So Wolfram Mathematica is a program. So I'll talk about the whole architecture. Okay. So now I don't have to access through ChatGPT. I can show you example, and in fact, there's some use case where I want to show you how to interact with ChatGPT, but that's not going to be the main thing today. With me so far? Okay. Everybody has downloaded. By the way, when you open this app, oops, can you check a little bit, help, and go to about, and tell me what number you see. Because your class should be downloaded after Wolfram 14 came out. I was hoping that the admin guy gave you this version. It's not that much different from 13 point whatever. What does anybody does not see 14.0? What do you see?
13.2 from the summer course.
Oh, okay, that's fine. That's fine. You? Same. Okay, fine. You can upload it. For what we do, not going to be significantly different. The difference is one of the major difference. Every version has larger set of functionality. With Wolfram 14, it also does the complement. Remember I told you about ChatGPT hooking up to Wolfram Alpha? Well, this is a bit like a reverse portal. This is going from Wolfram Mathematica linking to ChatGPT. Okay, so for example, let me show you this. Okay, just you don't have to follow me. Okay, notebook setting. I can say enable AI chat, and I can go to model, and you will see that this is linked to OpenAI. But of course, it's not exclusive. Just like OpenAI is not exclusive to Wolfram Alpha. It has a whole bunch of other back end. So this one you can have other engine as well. And Trophic, honestly, I have not used that. Okay. In fact, I haven't even used OpenAI within this. I just use OpenAI. So I'm kind of like, I don't have to go to one to access the other because I have both, right? Again, it's worth your money if you want to pay, but 700 baht or something a month. Okay. But if not, don't worry. Don't need to. Okay, fine. Let's go to blank page again. Now, it used to be, if you think about programming, okay, what can you enter? Codes, right? So I can enter code. That's obvious, right? So let's say I plot. Okay, okay. So for this class, I want you to try to follow the keystroke as much as you can. Okay, and it might come with error or whatever. It doesn't matter. And then save it. At the end of the class, you would submit your in-class worksheet to Dimutu as an evidence of your sort of like participating, I guess. So anyway, so this would be something like, okay, you notice, okay, let me go back again. Okay, in the beginning, it's good to go extremely slow. Completely blank, untitled 1, with a star, that means it's not safe. Okay, it's got nothing, nowhere, absolutely nothing. Okay, there's a plus sign here. Okay, if I put my arrow here, say choose new cell type. Now this is relatively new because in the old day there's only one type, command. Okay, so in the old day, maybe Mathematica 1, you would come in and there'll be just empty page. You say something like 1 plus 1. Okay, so let's do that. 1 plus 1. Now, if you enter, it doesn't do anything because enter just go to the next line. So the first thing you need to know is you shift enter if you wanted to do something. It's like over to you. Okay, shift enter. Okay, now immediately you will notice that there's a little cell here. Okay, this cell bracket around you, your input. Now it happens to be number 10 because I was doing something earlier. If I do it again, it's going to be 11. Okay, so input number 11, since I start the program. Okay, let me finish again. Don't save. Okay, I quit everything. And then it's quit. Okay, start again. Oops. Okay, if I start again blank, you know what polyhedron this is? Okay, so now if I go 1 plus 1, okay, 1 plus 1, shift enter. Okay, input number 1, output number 1. So output corresponding to this is this. And this one is my input cell, this one is my output cell, this one is the whole thing. Now all this can be nested, right? And maybe you can hide this and you can hide input, you can hide output, doesn't matter. Okay, don't panic. If chances are you don't see anything, go to the right hand side, these are the cells. So people who use like Python, Jupyter should be familiar with this kind of cell structure because it's copied from this. Now, so this would have been something like in the beginning, right? So computer code, you enter commands. Okay, what else can you enter? Well, you can enter comments. Now, if you want to enter comments here, you just go there's a special designation, open bracket, star, and then you can say anything. This is just a comment, so I don't forget. Okay, this does nothing, it's just a text. Okay, so in the old days, that's it, right? Okay, that's it. Okay, now again, I can delete this. Now, just because I delete, that doesn't mean it doesn't memorize. So it knows that it's already done one computation. If I did it again, it's going to be computation number 2. Now, click the plus button. Okay, click the plus button. Now, if I link to ChatGPT, which I haven't here, there's going to be like a AI dialogue thing choice. But right now, baseline, you have 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Okay, the bottom here is text. What it means is that it's just a text. So when you do this, you can just type anything. It's just a text, just like that star thing, except I don't have to make comment. It knows that this is a text. Okay, fine. Now you will notice that if you're going to write something more structured, it's going to be like heading, subtitle, all kind of stuff. So instead of just plain text, I can do any kind of other style of text. Okay, so for example, I can say, let's say section title. Okay, title, book title. It's just formatting. Okay, and it does all kind of stuff. So anyway, this is just text. Think of this as, so you don't have to have a program, go to Word for all your formatting. You can do everything in here. So that's just text. Fine. That's not that interesting. Okay. Now, up one step. This is also relatively new. This is not new. This is new. This is called external language input. This is for those of you who want to be bilingual. You speak Mathematica, Wolfram, but you also speak R, you speak Python, and you don't want to speak on a separate channel, you want to speak here. So if I, for example, in my case, I set up my external language to default to Python because I don't know R. Okay. So here you can use this as Jupyter Notebook. Okay. Sorry? Yeah, that's something else. You have to set up the environment just like in Python. So if your environment is not connected, you're not. So here, if your environment is set up, you have to import pandas as PD, just like a Jupyter Notebook. Okay, so you have to. Now, I've never used. Again, I'm not a super integrated guy, So if I'm going to work with a project that use Python, I would just go to Jupyter Notebook, okay? But who knows? You may be different. And in fact, there's some cases where this makes sense because I'm doing a whole bunch of computation, but there are certain algorithm that's implemented in Python. I don't want to waste time re-implementing everything, so I sort of like open a little window and say, hey, let me go do something in Python and come back. Okay, that's a normal thing nowadays. Okay, in the old days, it's very abnormal. In the old days, cross language, you just send flat file or something. Okay, so now it's a lot more fancy. I'm not saying it's an optimal or fastest way. I think there's a lot of overhead communicating. Okay, but okay, that is neither here nor there. So let's not go into that. But for you, data science, data analytics guy, this is relevant. Okay, now let's go to the top three. The top one is the language itself. The top one is the language itself. So this is clicking here is like by default. It's like doing this. Okay, now it's input number 2 because it did once already. Okay, fine. Not that interesting. Not that interesting. Okay, now this one is called free form input. This one I don't use. I hardly ever use this, but this is sort of like, you can think of early 2000s when natural language processing wasn't something on its own. It was sort of like a front end. So this is something like a chatbot for people who use. So I want to program something in Mathematica, but I don't know. So this is kind of like a little chatbot engine. So please plot sine wave or something. Okay, again, shift enter, and it's going to try to interpret. Okay, it's going to try to interpret. Is that what you want? So this is language, your language. This is the actual command. And if you think this is what you want, you just click it. That's what I want. I want to plot sine wave. So sine x. Actually, you don't even need this evaluate, but some function is a bit more computational, so you need that. So something like this. Okay, I could have just typed this if I remember the format. Okay, so you have no idea. You think you want to do something. You use the internal chatbot. Okay, you use the internal chatbot. It suggests the formula. If it's what you want, fine. Click it, and then you can adjust. So for example, this one is a function that plot the sine wave. Everybody knows what a sine wave, otherwise you shouldn't be in college. Sine of x, okay? Now, the first thing you need to know is that Mathematica doesn't use this bracket, it uses square bracket, okay? And then it uses curly bracket for a list of items. So right now, I will take this opportunity to teach you the basic way of programming the function. This is the function. This function has input in the square bracket. This function, because it's a built-in function, okay, pay attention to this. Because it's a built-in function, when I type it, it appears in black. Because Mathematica knows what it is. If I type in another function, it doesn't know. Plot crazy. This is a new function. It doesn't know. So it highlights in blue. Okay. Now I can define this. Once I define this, it would know. But until then, it only knows the, I don't know, 50,000 built-in function, which is already a lot, right? So this function has two arguments. Okay. How many arguments does sign take? One, right? Sign of something. Okay. How many arguments does plot take? Well, plot takes two arguments because it has to say plot what, right? Over which range. So this is the range of x over which it plots. So if I shift enter, so by now you should have typed this in, right? Plot, open bracket, sign again. Now, if you by mistake type in little s, you will notice that it doesn't know. So it's case sensitive. Okay. So plot sine x between -6 and +6. Get that? Okay. If you don't like it, you can make it -6 to +2. Shift enter. Okay. Now, here's the first fun thing I want to show you right away before I even go any kind of further than this. Look, this is a function, sine wave, right? This is a function to plot it, right? Now, to make the whole thing interactive, okay? Again, you should be typing this in and hand this in at the end of the class because that, you don't have, maybe I give you take home homework. Anyway, let's do something fun. Instead of plotting from -6 to +6 or whatever, what if I want to change my mind? Okay? Minus something to plus something. Okay? In that case, what I can do is instead of putting real number, I put some number from, okay, from, okay, so F. Well, actually, I just make it A, from -A to +A. Right? So first, what you should do is do this, right? So it's got -6 and -6. So that's this. Don't erase it because you want to show your work at the end of the class, right? Just copy it and then paste it here. Okay. Now, if you paste it, notice it hasn't been executed. If you shift enter, it executes again. So not interesting. So now what I want you to do is instead of -6 to +6, I want it to go from -A to +A. Okay. Now I want to put this inside another function called manipulate. Manipulate this thing. Manipulate, you know what the word manipulate is, right? Come from the word manufacturing, manipulate. This is all about hand. So I want to hand tweak the A. So now this whole thing becomes a function, becomes an input. This is what makes it super cool. You don't just input number, you can put the whole function. So this manipulate expect two things. One, manipulate what? Two, with respect to what button? Okay. So in this case, I want to manipulate A. So the second argument to the manipulate function is A. And let's say A from, I don't know, 1 to 10 or something. Close bracket. Okay. So see that? I can make it explicit. Looks like this. Sine has one input. Plot has two input. One is the function. One is the range. Manipulate has two input. One is the whole thing, the plotting function. The other one is the button. Shift enter. So now it looks like this. This now, A becomes a button from 1, and I can move it to whatever, 10, right? Okay. Now, I don't know where your default setting is. Your default setting may have this thing to the right. I kind of don't like this layout, so I'm just gonna put in optional, okay? So, okay, let me show you something. When I erase this, okay, let me cut this. You notice that there's a little prompt here. That prompt says, I'm not done. You need to stick in 2 things. So I put 2 things. However, I can add optional command. So that optional command happened in this case, okay, is a controlling the appearance. So let's say I want control. By the way, when you start typing, it gives you the suggestion. So you don't have to worry about, so control type, no, I want control, yeah, I can do control type. Control type. And let's say by default, it's a slider. Okay, fine. Same as before, because this is default. So notice this thing is exactly the same thing as this thing, because it's an optional specification. But if I didn't do this, control type, okay, type in the word control type, and then minus greater than, that becomes an arrow, and that gives you suggestion. So let's make it a pop-up menu. Shift enter. Oh, doesn't work because it's not continuous. Let me do this for you. Don't ask me what. So now it does pop up. Okay, now it pops up. Okay. What I did was pop-up menu has to be discrete. 1 to 10 is not discrete, so I have to go from 1 to 10 instead of 1. Okay. If I did this 1 to 10 instead of 2, it's gonna go 1, 3, 5, 7, 9. Okay. Anyway, so let's say I want to do this. Now let's try something else. So this is my extra. So let's have another extra. Control placement. And to the right. Okay, now it's on the right. Okay, fine. Okay. Right now, this is something that I want you to have sort of like stuck in the back of your mind, because this is the most simplest way of you to interact with new, let me call it learning object. Okay. Now, so here, now I'm going to spend a bit of time talking about, semantics and all that stuff. But right now, what have I just given you? I have given you this line of code that communicates to Mathematica what I want, and what I want is this. Okay. So let me try another one. Okay. Now, okay. So let me put, so line break doesn't mean anything. So I'm gonna put everything back in the same line to make it more compact. Same as before, right? Shift enter. Now it's command number 16. I shift again, it becomes number 17. It doesn't matter, just keep running. Okay. The point is, this is your command. This is what you get. Okay. If this were a programming class, what would I focus on? I would focus on the syntax and whatnot, right? If this were an interactive user interface design class, I would give you an hour just on the options, right? Because when you build user interface, you want to, dress it up, make it big, make it small, make it blue, make it green, make it round, all kind of stuff, all kind of formatting, all kind of placement, okay? But today, that's not your business. Your business is learning about new technology. So in this case, what I have given you is a way of learning about the sine function. So in other words, okay, in other words, you know what a sine function does, and you interactively learn some parameters associated with it. Now, this is not that interesting, right? Because this is sort of like a range of function. Now, I'm going to do something else. Hold on. Let me change a little bit, okay? Let me change a little bit. I'm going to make this, okay, copy. Again, don't destroy the old one because you can use this for learning. The next step is I'm going to make minus, okay, minus, watch this. Go to escape. Okay, I don't know about MacBook book. Do you see that 3 little dots? Okay, and it's gonna just, and then you start typing pi for pi, and then escape. Okay, this is shorthand. This is shorthand. Okay, now, okay, look up a little bit. If you go to palette, okay, palette is like any other software, you have palette. Special character, you would see that you have, you know, Greek letter. So pi is kind of here. Okay, pi is kind of here. So it's actually just a shorthand pi. The difference is, and here's the difference, pi is universally a constant. Okay, it's a transcendental number approximately equal to 22 divided by 7. Okay, so when you type in pi, it's not like A or B. Okay, if I type in A, it's blue because it doesn't know what A is. Okay, if I type in Jeff, doesn't know who Jeff is, right? If I type escape, pi, escape, it's black because it knows what pi is. Because anyone beyond 5th grade should know what pi is. So therefore, it knows what pi is. Okay. Now, so I wanted to plot from pi to minus pi to plus pi. Oops. Okay. Now I put A times X. Now, A times X is just A empty space X. Okay, you can put in multiplication sign, but nobody does. It's a waste of time. So now watch this. Watch this. Okay. Now it's A times X. Okay. So now A is equal to 1. And as I increase the frequency, what happened? Right? So again, if this were a programming class, you would have to know, I would focus so much on all this function and all this formatting, right? Which you have to know a little bit. Yeah, not much. If this were a class about interactive GUI user design, I'll be playing around half an hour with just making it look pretty. Okay? Control placement, I can make it a button, I can make it a control type is a button, it's a draw down, it's a turn up, all kind of stuff. So I would focus a lot on here. Yeah. But now the idea is that you don't have to change anything. This is it. But focus on this. Pretend that you have never studied sine function before. And sine is a new technology. Do you get what I mean? Okay? Pretend that sine of AX is a new technology. You don't know what it does. You're trying to learn it about its behavior. So now you know, A, if I make A big from 1 to 10, this thing kind of like bunch up. Right? Okay. And I can do some other thing. Okay. I can add B. And this is kind of like going to shift things along the B axis. But right now, this is it. Okay. So why is this a learning tool? This is a learning tool because, number one, you give it something you want to learn. I want to learn sine function. Please show me what it looks like. You can do that with Wikipedia. You can do that with textbook. It's just going to give you one picture. But now you want to learn more how things work by tinkering. Okay, this is the art of tinkering. Hey, what happened when I make A bigger? I can also make A smaller. Okay, how am I going to do that? I use this interactive user interface. So with Mathematica, the cool thing is it has a huge library of all this function. So chances are any kind of technology you want to learn, it's already built in. Okay. Second, it gives you this parametric control. So let me give you another example. Okay. Example. Now this is I'll give you just an example and you just type along. Okay. Example data. Open bracket. Okay. And put in double quote. And it's going to give you a whole bunch of stuff. So maybe something like, I don't know, chemistry maybe? Data set. Okay, data set. Shift enter. Oh, whole bunch of things. So let's do this. Let's say, you can actually use Google or chat here. Let's say Mathematica. Okay, now this you can use ChatGPT or Google. And let's say you don't know any better. You can use this. You can use this thing as well. Okay. But another thing is just go to Google. The reason why I would even suggest you go to Google is because sometimes you would actually get into a conversation. So there'd be like a just like with any other language, there's a user community. So if instead of relying on yourself to say something like okay, Mathematica, how to plot molecule. Okay. I know how this works, but okay. This one happened to go to a help page. That's not interesting, but you can go to sort of like user Reddit or all kind of stuff. But anyway, okay, let's say you don't go to Reddit, you go to here. So what happened is, okay, so you get this idea. Go to a help page called molecule plot. Okay. Again, this is you have to be very Basai student have to be good at one thing. Getting in and out using different doors. So this is one door, right? I use Google and I search. Okay. Well, here's another door. Let's say you have an idea that you want to do some kind of plotting with molecules. So you type in molecule. Oh, there's a word there. Hey, molecule plot. Okay, that looks like something I want. I don't know how to use it. I could go to Google, in which case, just now, or I can go to, now this is where I don't know about MacBook, but in normal, try, do you guys have F1 in MacBook? Okay, try press F1. Okay, see if that comes up. Anyway, it should take you to kind of like roughly the kind of this page, molecular plot. Okay, so molecular plot, for example, now, what if I want to plot, and let's try this. I don't know chemical thing, so caffeine. that how you spell it? Let's try. Ah, it is. Okay, caffeine. Okay. And what else do you have? Let's try LSD. I doesn't have. Let's try, I don't know. What else you got? Amphetamine. I don't know how to spell it either. Okay. Okay, good. Now, okay. So let's say you have a project. Okay. Notice right now, this is about learning sine wave and what happens when you increase the A. Now I can do this just like this, copy and paste. But now instead of molecule plot, I can do this. Instead of plotting the sine wave, I can do molecule plot, right? And now I have to say something like item. Okay, whatever that item is. And that item is, now it's a list of things. So let's say caffeine. And what's the other one? Amphetamine. Let's say I spell right. Okay. So there it is. It's okay. So now amphetamine, oops. Amphetamine looks amphetamine. Oh. Okay. So now this. Of course, Mathematica has a database. So it's not just these two things. It has 500, whatever. I don't know. Ask Dimutu. Your TA, by the way, is a chemical engineer, right? So how many chemical basic molecules is in the database of Mathematica? Probably 20,000, I don't know, okay? But I don't know any of those, okay? I just know caffeine and amphetamines, okay? So there. Now, of course, you can also, okay? Let's say I want to be a little bit more fancy. Okay, so this is item, right? So notice this is item. But now I want to sort of like try a different way of plotting. There's another way of plotting. It's called molecule plot 3D. Okay. So if I did this, instead of this, I put in 3D, come up with something else, right? Again, this is presumably the technology you want to learn is chemistry, okay? Now, let's do something else. Not only is item subjects to change, you can also change this, right? You can say, hey, I have my choice of plotting. Comma. Plotting. Okay. What was it before? Molecule plot. So this is how powerful this thing is. Not just the variable, the function itself can be chosen at will. Molecule plot 3D, right? So now, one thing is you have to be precise about bracketing. Now, this is something that Mathematica is very high level. It kind of understands what you want to do. So it's very friendly, okay? This is why I use it for Basai student, because Basai students are not all coders. So it's very friendly, it's intuitive, it's less, it's functional programming, but it's also what's called decorative in the sense that you don't just give it the function name, you kind of like tell it what to do. My intention is to get a plot. So it's very friendly. One thing Mathematica is not friendly with respect to is bracketing. Okay, so if you don't count your bracket right, things don't go right. Like if you miss one, it's not going to fill in for you. Why? Because controlling the bracket is something is very precise. It can't guess what you want to do. Okay, So one thing that's not friendly, you don't expect Mathematica to fill in all the bracket for you, okay, unless you use that kind of chatbot thing. Shift enter, oops, see, I put in too many, doesn't work. I move one down, now it works, okay. So now I can go caffeine, amphetamine, 3D plot, 2D plot. Okay, one thing nice about 3D plot is that it gives you a, I think this is carbon, right? Right? Something like, whenever you see something like this, chances are it's carbon because it's got a 4 thingy. And this is probably oxygen, I'm guessing. Hydrogen, oh, my bad. And what about this? Okay, see, it's good to have them. What's the blue one? Nitrogen, okay. Well, you can have this name, but you see what I mean, yeah? So this is a lot nicer than just now. Well, this one, yeah, this one has a name. There are many ways of plotting, okay? In fact, you can specify a whole lot more, yeah. But so now you see it's nitrogen, carbon, oxygen, hydrogen, yeah. And this is what it looks like. And presumably, as the data gets updated, you can go to coronavirus protein, what it looks like or something. I don't know if it's not there already. Okay, but these are simple. Okay, protein are humongously complicated. All right. So this is basically it's just starting from what I show you, right? So now let's go start from zero again, start from scratch. Plus, now this thing and this thing I consider equivalent. So this is command when you know what you're doing. This is kind of like asking the internal chatbot to help you because you don't know the exact command. But to be honest, I rarely ever use this feature because if I know what I want and I type in the word like plot, start with the big P, chances are it's going to do autocomplete for me. Okay. And if not, I go to Google or Mathematica community and usually get something very good suggestion from it. Anyway, so last thing is this guy. This guy is equal with the star. Okay. Equal with the star. If you click this, okay, watch. Okay. Guys, look up. If you click this, the prompt will have this kind of funny shape. This is Wolfram Alpha. This is exactly the same thing as the plugin on the ChatGPT. If you paid for ChatGPT Plus, you can, again, ChatGPT Plus means you pay for ability to add plugin. And there are 200 plugins, I think, right now. The most popular are Wolfram Alpha, something about PDF link reader, I think. A few of them, the top 10. Anyway, Wolfram is in the top 10. Okay. Another one would be like text summarizer. The other one would be something like Trip Advisor or something like that. Okay. But if you look at in YouTube, it shouldn't change, I think. Let's see. YouTube top 20. Okay, let's say top 20 chat GPT plugin 2000. Let's make it 2023 because we haven't moved that. Oops. I meant to go into YouTube. Okay. Right. Top 20 best. You see that? There are 4. This one is the Wolfram Alpha, this little spiky thing on the top right. And the carrot, I'm not sure what carrot is. Anyway, go click in there and it should be in there. But so yeah, so it's got a few link reader K, I think it's Kaggle. I'm not quite sure. Anyway, so there it is. This is a spiky. This is spiky. So this is our Wolfram Mathematica. Wolfram Alpha. The difference between Wolfram Mathematica and Wolfram Alpha is this. Wolfram Mathematica is platform for programming for computation. Wolfram Alpha is like knowledge base that can then provide you with real data to compute with. So you can think of it as one is a function, one's a database, intelligence database, okay? And Wolfram is the last name of the guy who started the whole thing. He's a physicist, by the way, okay? So Wolfram Mathematica is a programming language, but instead of just operating on spreadsheet or operating on the data you provide, one of the things it can do is connect to Wolfram Alpha, which is a curated knowledge base that can be downloaded or lifted, whatever, to do computation. And that Wolfram Alpha is the same spiky thing you see in all this top 10 ChatGPT plugin. So anytime you see spiky looking thing, see this little sign here, that's Wolfram Alpha. Yeah, this is Wolfram Alpha. I don't know what a caret is, but I see that a lot as well. Do you know what a caret is? But yeah, K and caret, I'll have to find out. I don't use it, so I think I use the link reader. Okay, fine. So this is what this is all about. Now, notice this is the tool to learn about science. This is the tool to learn about chemical things. But what about if you want to learn about something and you don't know where to start? Anybody want to start with something you want to learn about? Anybody? Fine. Don't have anything. I'll just well, it's not technology, but maybe astronomy. So let's say something like Pluto. Sorry. Yeah. Okay. How about electricity Thailand? I don't know. Okay. It's gonna look up Thailand. It's gonna look up electricity. Now, I don't I don't use this as my database. So I'm not familiar with, say, utility database, but presumably it has to do with kilowatt, kilowatt hour per year. And all this, once it's down here, you can sort of like connect to it and do computation. So this is just initial plot. You can kind of like take this data object and plot, and maybe one of the things you manipulate is the beginning year. Instead of beginning so far back, maybe starts a little bit later. So this is, again, think of this as knowledge that's curated. And if ChatGPT, whenever ChatGPT you prompt it and it say using Wolfram Alpha, you can be sure that the information is correct. No less correct than when you use it here. So I'm very certain that based on the latest data set, now it happens that Thailand doesn't have that many active, so the latest is 2012 estimate, fine. But if you use other country, maybe it's more recent. Okay, so this is Thailand. How much nuclear energy do we have? 0. Renewable, fossil is a lot. Okay, it's quite disappointing. Okay, so let's try some other country more interesting, maybe. Let's try Laos. Let's see what happened. Again, so this is curated data. Now, you see all this plus thing here? You can, click and download and all kind of stuff. Now, let's see what Lao does. I would imagine that their renewable is more. Fossil, oh, not good either. That stinks. Oh, no. Sorry, my bad. I should badmouth them. This is billion, guys. It's a huge improvement. Okay, so it's 1/10. Laos. They're renewable 11 billion, and only 1 billion is fossil fuel. Compared to Thailand, which is like 20% renewable at most, at best, I think. Well, you shouldn't be surprised, right? Because Laos actually produced their hydroelectricity to Thailand. Yeah. We used to have electricity produced by the hydroelectric dams in Thailand. And then that, as we became industrialized, that amount is no longer sufficient. So we have to import gas from the Middle East. We have to dig natural gas from the Gulf of Siam, Thai. We have to also import hydroelectricity from, I think, Myanmar, definitely, and Laos. And Laos, yeah, they use like, yeah, 90% of their electricity is renewable. And not only that, they sell some to Thailand. Okay, so these are facts. So you learn about sustainable thing, you learn about energy, you learn about, I don't know, virus or something like that. Okay, so maybe something more interesting, I don't know. Now, you don't have to go to plus here. There's a shortcut, which is equal. Watch this, guys. If you go equal, it goes to that internal chatbot. If you go equal, it goes to this Wolfram Alpha. It's a shortcut. You don't have to memorize it. Okay. But let's say maybe, I don't know, let's see coronavirus. Seems something interesting. COVID-19, 600 million. Now, I didn't ask about Thailand this time, but it kind of guessed that since we were obsessed with Thailand, I guess, it's a number for Thailand as well. Yeah. But of course, the star of the COVID story is United States, and that's, yeah. Okay, so all kind of stuff. So this, okay, this is you connecting two things. Intelligence, by which I mean knowledge base, Wolfram Alpha. But Wolfram Alpha, if you access it through ChatGPT, you just get the knowledge base. But if you import it here, you can take this data set, you can do analysis. Maybe you can do, I don't know, some kind of modeling. Okay? This is where you can do more than just manipulating. But if the first thing you manage to do is get the data, get the subject, I call it learning object, the object of your learning, put it down here and manipulate it, you start to get insight. Right? You start to get insight. Now, does that make sense to you why this modality matters? Now, obviously, nobody beyond 5th grade or maybe 7th grade gets excited about sine wave anymore. Okay, but there's plenty of things to get excited about. So this is where community comes in. Okay, this is where community of learner comes in. People who are very nice, who are very intelligent, they learn about something and they do this. They want to learn about sine wave, so they play around with the sine wave, blah, 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 blah. Now imagine it's not just a sine wave, but it's something more complicated. So they learn about it by doing this, not just manipulating A, maybe they manipulate B, C, D, have all kinds of stuff. But once they've done the learning themselves, they want to share it. Where did they go and share it? Go to Google, type in Mathematica demonstration. Type the word demonstration and mathematics. Basically, you start Mathematica, so you are in the universe. Wolfram and Mathematica, they kind of same thing. Wolfram demonstration project. By the way, originally, Wolfram's the name of the guy, and the program is called Mathematica. And later on, he makes a distinction between the program and the language, and he calls the language Wolfram. So sometimes I'll use the word Wolfram language, sometimes I'll use Mathematica, but Mathematica is the whole software thing. Okay. So what I'm going to tell you is that in the 70s, say Mathematica 1 was literally just a programming language for doing mathematics, not even data science, not even statistics. It was designed to do physics. Okay, and now it does data science, machine learning, AI, large language model, interactive visualization, prototyping, system, all kind of stuff. So it became what's called an ecosystem. And this is a word that Basai students should understand. You never, ever have a software anymore. In my generation, we have hardware, software. That was the world. There was the world of hardware, and there's the world of software. Your generation is the world of platform and ecosystem. The platform itself sometimes involves hardware, sometimes does not involve your own hardware because you go to cloud. Sometimes involves software, sometimes doesn't involve software because you can ask ChatGPT to write the code for you. Okay, so the two big words in my generation is hardware and software. You learn hardware, you learn software. You're a computer scientist, you are a software engineer, you're a hardware architecture specialist. Okay. Your generation is more like platform and ecosystem. An ecosystem, by the way, we don't have a course in this yet, but I think at some point we will have to. So there's this Wolfram Mathematica ecosystem, which is huge. It's not as big as Python ecosystem because Python is free. It's a little bit like Android and iOS. Which ecosystem is bigger? iOS is always going to be a bit smaller than Android because Android is an open system. It's easier to access. You don't pay as much to the broker or the master. Okay, with iOS you pay a lot to Apple because they own the whole infrastructure thing. So an open system is going to be larger. Likewise, Python is also a platform and an ecosystem. It's much bigger. It's much bigger. Okay, but unless you're a programmer, it's hard to get into. So this would be something that so right now we have what? We have the software itself. We have the help page, right? The help page. So that's an ecosystem. We have a community of user. And one of the big part of the community user is the demonstration project page. And this is your homework number 2. Okay. Your homework number 1 is basically to turn in whatever is in front of you. Okay, by 16:10 or something. Okay, as an evidence of your work. Okay, you can have other exploration you want. Now, your homework number 2 will be to go into this demonstration. Find something you like. Literally. Okay. Something you like. I have no idea. Again, we'll take a quick break. We'll come back. We'll start talking about your kind of subject of interest. Okay. Just a bit of, I guess, self-promotion. I actually wrote one in here, but it's not that interesting. It's about banking and finance. So if you're interested in banking finance, so this is sort of like highlight, right? But actually what you do is you browse through the topics. Right? So the one I wrote will be something in here, I think like social science or something. But kids and fun, creative art, our world, programming functionality. So let's say you're interested in something in life science, or okay, let's start 2 pages. One's life science, one is maybe engineering technology or something. Okay, and you can also, of course, do search. Like for example, quantum computing, which I'm going to teach after midterm, I think. There'll be some example on that too. Plenty. Okay. Okay. So you would notice the screenshot. This is a screenshot, right? Everything looks just like what we did. All of this is based on manipulate function. Okay, except the background is in gray rather than white. I don't know why. In my computer, it's also gray. I don't know why when I show this to you, it's in white. But in my computer, it also looks this, and I think they just make it a standard that put everything on top, so it's not on the bottom. So let's say control placement on top. So everything will be on top, and this will be gray. So that's it. That's everything would look just like that. Of course, there's a lot more. Now I'm gonna pick something at random. Okay, I have no idea what I'm looking at. Let's say Deutsch algorithm. Okay, never mind. It's never mind. These are all the things that you can play with. This is a good screenshot. Remember, this is like a slider. This is like a button. So there are two things to play with. And by playing with it, now let's do this. Yeah, let's okay, you go to your assignment is to go to the page that you like, pick up the subject you like. Okay, and then come here, source. Okay, you can download to. Okay, now if you download this to desktop, let's see what happens. To desktop. Okay, it's gonna ask you to download Wolfram Player. You don't need to. Okay, what happened is this: a Wolfram Player is sort of like a play-only version of Mathematica. Okay, but you have a programmable version of Mathematica. So the play-only version of Mathematica is free. Anybody with an internet can access. Okay, but you, Basai, already paid a lot of money for that Wolfram Mathematica. A lot, by the way. Not insignificant sum. So you don't need to download the player because you have that. Because you don't have this the player. Okay, let's go look here. Okay, let's go to the download. Ooh, why do I have so many things? Oh, okay, that's mine. Okay, so look, when I download it, I have this thing called Deutsch algorithm on a quantum computer .cdf. That's very important. CDF stands for computable document format. That's the interactive textbook that I was talking about. If you don't have Mathematica, you don't want to buy Mathematica, you can download a play-only version, and you can click on this, and you can play with it. So this is one function, this is two function, random function, okay, all kind of stuff. Now, you have no idea what this does, right? Basically, these are called quantum games. You will learn about this, right? And in fact, I might even use this to teach you. Okay. Basically, they always say the word about quantum state, about entanglement. Well, this is what it means by entanglement. Okay. So you have a state of 0 and 1, and the 0 and 1 becomes together, and then you have some kind of computation. You have computation, and then you do some kind of detection. Anyway, the point is that's all you can do. And these are the explanation. So think of how cool this is. If you look up Deutsch algorithm in Wikipedia, you will certainly get this. You will not get this. Right? So let's, if you don't believe me, let's go to Wikipedia page. Algorithm Wikipedia. I mean, Deutsch, yeah, same thing. Okay, let's do this. Okay. It refers to this. So it has a whole bunch of write-up and it has a picture. It has one picture. You can't play with it. Everything's static. Right? Whereas with this, you get the explanation. It tells you what happened when you set to F1, you F2, and then you go see, I see what it does. Now this list is a little bit opaque to you because you haven't got the first thing about quantum computing, so it doesn't look like it's going to teach you anything, right? But yeah, certainly maybe you need some background understanding. But once this kind of exploratory learning is what we mean by a tool for lifelong learning of emerging technologies. So imagine that in 50 years' time, there's something else even fancier than quantum computing or something else fancier than large language model. You can't figure out yourself. Hopefully there'll be some guy who figure it out by playing around with this manipulate and put it down, upload it on a demonstration project page. And then you can learn from that guy. Okay? Now, so again, this is just a free version, right? But because you have the full software, instead of just download to desktop, you go to the source. Go to the source and then download to desktop again. Yeah, I'll show this again. Yeah, so you can download anywhere, but I mean, post to desktop. Now, notice I have exactly the same name file, but now it is .nb and has the word. Can you guys see it? It has the same name, Deutsch algorithm on a quantum computer / author. So this is actually what the author submitted to the platform. .nb. NB is the Mathematica notebook. Remember that Python notebook kind of borrowed this structure. So that's why they have the last name IPYNB. Interactive Python notebook. Okay, but the original OG, original gangster notebook is just .nb. It's Mathematica. Okay, so Python came later, so they have to add IPYNB. So this NB, when you click it, it's slightly different. It has all the text, but it actually has the code, and you can literally play with it. And you can, well, these guys are generous. They don't hide what they learn. You can copy this. Okay, there's nothing in here that say, you know, copyright or some author hides a little bit. Most authors don't care. Most authors share everything. Okay. In fact, when COVID-19 came, I developed an infection model that has a parameterization of adjustment rate of COVID. Okay, I came up. But because when I want to show this concept, the baseline, what's called SIR, susceptible infectious recovery death rate, is a partial differential equation and it's implemented already in Mathematica. The basic baseline model I actually copied from one of these guys. So I don't start from scratch. There is some, I can show you. So anyway, so this is the one, right? So this is the one about physics, but let's search on this SIRD model or SIR. There it is. I think this guy. Okay. Now, obviously, okay, I don't have to download. This is the SIRD. It has all this parameter. Okay, it has all this parameter. I download it. Download to desktop. Okay, I download to the desktop, and this is how I learned the mechanics, because I was trying to do it from scratch. Originally, I was trying to do it from scratch, and I kind of ran into some kind of syntax thing I couldn't work out, so I copied, right? And they don't care. They want to share this. So this is the baseline differential equation. This is how you, okay? So based on this with 1, 2, 3, 4, 5, 6, 7 parameter, I went and did something like, let me see. And this will be the last thing before the break. Boom, 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 boom. What did I do? Pedagogy, COVID. COVID analytics. Okay, so I created this COVID library, and well, this is just a screenshot, but you will see that the original model, right? It has an infection and parameter 1, 2, 3, 4, 5. My model happened to have more parameters to tune, so I add a whole bunch more to the right-hand side. It just gets too big to the top. Okay, And these are all the parameters: infectivity, dissipativity, fatality, error rate, right? This is prediction, susceptible, day one. And my model was very good. It was very good up until the second wave. Then everything just blew out because this model only takes one shot. Okay, so so this one disease model was parameterized for Thailand. I think the screenshot was 2007. So this was only 7 months in, I think. Okay, and just to share with you guys, so you know that this is not. Let's go to YouTube again. Let's go to YouTube and NACASQL. That's me. Let's go to there. Let's go to my thingy and playlist. COVID analytics. Okay. So this COVID, I make Thai version and English version, but this is basically the COVID analytics that was developed, and I outline how this was adapted from the SIR model. Okay. So again, so not only can you learn, you can extend. And in fact, the biggest, I would say, the most rewarding motivation for learning is the promise that maybe you can add a tweak. I don't know if you have this kind of drive. We didn't have School of Innovation when I was growing up. So I was never thinking about innovation. But you know what my generation was thinking? Invention. I was always thinking, wouldn't it be nice to invent this and that and this and that? And because I'm not that smart, I don't invent something from the ground up. Like Michael Faraday with electric. I don't have that kind of talent. But I like inventing. Yeah, I wasn't thinking about innovation. I always like to think about, hey, this thing, wouldn't it be nice to have this kind of tweak and that sort of thing? And this is perfect for me because, hey, I don't have to start from scratch. And this was an epidemiology model that was not my specialty. I picked this up during COVID. It's nothing to do. I was kind of doing consultancy, and during COVID, there basically no project. So I learned this from scratch. Again, I didn't have to start from scratch because some really nice guy somewhere posted SIR epidemic model on Mathematica. I pick this up, I make an extension. Okay. Now I could have gone on and developed this into an academic paper or maybe patent, but once the second wave came, everything was gone to smithereens, so I didn't care anymore. Anyway, you can do exactly the same thing. Probe, remember that ingest, survey, probe, imagine, and this is the probe and imagine part of that phase. You probe into what the model is, and you imagine if you can do something to it. In my case, my imagination was I tamper what's called adjustment. It's like once you have an infection rate, you have sort of like a recovery rate. But the recovery rate could be sort of like parameterized so that presumably, you learn a little bit. You knew how to, when the disease came, you didn't even know how it was infected. You didn't know if the mask was effective. You didn't know that wearing a mask is not good enough, you have to wash your hand. But afterward, you learn mask plus hand washing plus social distancing, perfect formula, right? So your response rate, your recovery rate, and all that stuff improved. So this is something that was no longer static; it was parameterizable. So I took that. I think that was the gist of it's 2-3 years ago, and I tend to forget what I did. But it's that sort of thing I wanted to do. I add the adjustment, behavioral adjustment parameter to it. This is just something for fun in my downtime, right? But you have a future ahead of you. So for you, it's not just something for fun in downtime. It could be something you build your career on. Okay? So this is the tool to probe. Right? But so you probe the subject, and remember that ingest, probe, survey, imagine. Well, after you survey, you go back to probing, but now you don't just probe the key point from the video. Now you literally probe inside. Okay, so this is different kind of probe. This is actually kind of like dig deeper. Okay, it comes after you can imagine what you can do. So I would, for example, you can imagine that, let's say I was doing the survey and the survey told me that to model disease spread, there's SIR model, there's SIRD model, and the D and the R is a static. Then I imagine, what if the R is not static? What if the R can be parameterized? We can get more accurate prediction, say. So that's my imagine. How do I show that works or does not work? I put it to the test. All right. So none of this is an academic exercise, guys. And this is what I expect you to do for your project. Now, some of you may be involved in high technology, programming, genetic sequence in R, in which case, this is probably not up to the task. But for most of you, sustainability side, smart city, IoT, all kind of stuff there. This is not a, so IoT, you'll be in here somewhere, like system models, discrete model. IoT is a lot in there. Game theory, generation of form, all kind of stuff. Maybe it's a bit hard. Yeah, probably more IoT is probably more in here. Image processing machine, certainly mechanical engineering, nanotechnology, right? We're gonna start in nanotechnology. Okay, we're gonna take a break, but